Question 1. Okay, a particle P is moving along a straight line. His displacement is given by this. Find the value of t at the instant when the velocity is 8. Okay, so guys, this question it's one of these like displacement velocity acceleration questions. So if that's the displacement, how do we get the velocity? Well, we differentiate. So we're going to get ds dt to get the velocity. ds dt is 3t squared plus 8 t minus 27. That is the velocity, and we want when the velocity equals 8. So let's just make this equal 8. Then I'm going to subtract the 8 and I get 3t squared plus 8t minus 27 minus 8 is minus 35 equal 0. And then we can factorize this. I'll just do it my way quickly, guys. 3t and t. 3t and t. I'm going to go with 7 and 5, and I'll do it like this. 7, 5. This will be plus, and this will be negative. 3t minus 7 times t minus 5 equals, t plus 5 equals 0. 3t minus 7 equals 0, or t plus 5 equals 0. T equals 7 over 3, or t equals negative 5. Now, of course, t has to be positive because it's time and it says it there. Therefore, this is the correct answer. We will reject this one, and it is this. T equals 7 over 3. Okay, question 1. Question 2. Find the set of values of x for which this is true. Okay, so this one, guys, it's only worth 1 mark and should be straightforward. So we just rearrange. So let me just write it. 3 plus 2x less than or equal to x plus 2. X is on the left, 2x minus this x, and then numbers on the right, minus this 3. This is x less than or equal to minus 1. Easy. B. Quadratic 8x squared plus 10x minus 3 is less than 0. So first subtract the 3. Factorize this. Do it however you want, guys. I'm going to do it my quick way. 4x and 2x, 3 and 1, plus and minus. So 4x minus 1 times 2x plus 3 less than 0. Then we sketch it, guys. We sketch to solve a quadratic inequality. Graph it. Now, graph this x and y, this, and then we get the 0. So this is 1 over 4, and this is negative 3 over 2. We then sketch these guys. So 1 over 4 is like, I don't know, here, and 3 over 2. Sorry, it's negative 3 over 2. Negative 3 over 2 would be here. So this is negative 3 over 2. This is 1 over 4. Sketch it. It's a positive quadratic, so we go down through that and up there. Terrible drawing, but whatever. Where is this less than 0, guys? So it's between negative 3 over 2 and 1 over 4. So the answer is x is bigger than negative 3 over 2 and less than 1 over 4. Part C then, we need both of these to be true. So x needs to be, and just be careful, guys, if it's greater or equal to or just less than or greater than or whatever. Is it strict or not strict inequalities, which determines this equal sign or not. So x has to be less than or equal to negative 1. It also has to be less than a quarter. But if something's less than negative 1 and less than a quarter, that just means it has to be less than negative 1 or less than or equal to negative 1. In this situation, the quarter doesn't actually matter because this is smaller. And then it has to be, of course, bigger than negative 3 over 2. And that's it. That is question 2. Question 3. Okay, figure 1 shows a triangular pyramid. base is all this. We're given all this. Okay, fine. The face BCD of the pyramid is an isosceles triangle with BD equaling BCD, which is 26. Okay, fine. And okay, calculate the length in centimeters of AM. Okay, so we want AM. So guys, it's given AB is 10. This is 10. This is 10 here like this. And he wants this length AM. Now, let me just draw a line from A to M. Okay, so this is obviously a right angle here. He says, what does he say? BAD, so that's 90 and that's 90. And C, okay, that's not 90. What am I missing? BC is 16. Okay, sorry, this is what I'm missing. BC is 16. So this is 8 and this is 8. I'll call this X. I'm going to write up all over the place, guys, just so you can see, but you write down below. So this is just Pythagoras' theorem. And guys, I know this is answer 6 because this is a famous Pythagorean triple, but x squared plus 8 squared equals 10 squared. X is equal to, that's 100 minus 64. It's root 36, which is 6. Okay. B, calculate in degrees to the nearest degree the size of BCD. Okay, so he wants BCD. Okay, now we have, in this triangle, guys, we have BD is this is 26, this is 26, and this is 16. So we essentially have like a, well, we have a triangle, and this is 16, 26, 26, and we want to find this angle, theta. This is cosine rule. So we can say cosine rule, I forget what they give you guys, but you can do cosine rule. Cos of theta is equal to this squared plus this squared minus this squared. No, sorry, what are we trying to find? We're trying to get theta. So it's this squared first. It's 20. No, it's not. It's this squared plus this squared minus this squared. So this squared plus this squared minus this squared plus this squared minus this squared, all over 2 times this times this. 2 times this times this. Theta is then the inverse cos of that, right? I'm in radians, guys. Change this to degrees. Okay, thank you. And then I'm going to go inverse cos fraction. Well, 26 squared minus 26 squared, guys, is gone, so I can ignore that. So it's 16 squared on the top, and then it's 2 times 16 times 26 at the bottom. Close the bracket, and we get 72.079. 72.079, which is to the nearest degree, 72 degrees. Okay, finally, the size of the angle between the planes BCA and BCD. So BCA is this bottom plane here, and BCD is this kind of front triangle. Now, this is kind of hard to see, guys, but the angle we're looking for is DMA. So I want you to kind of imagine you move to the side and you're looking at it from this side here. Looking at it from here, you would have D. Let's hope that's a decent triangle. Okay, good. This is D at the top, and then A is here, and M is there, and this is a right angle. So we're looking for that angle there. Now we have, guys, we have MA. That is X, that's actually 6. And then this or this we don't have, but we can find it. I think I'll actually get DA, guys, because let's just call it Y. DA is Y here. So that means let me just do this here. Y squared plus 10 squared equals 26 squared. Y is equal to the square root of 26 squared minus 10 squared. Pythagoras, square root of 26 squared minus 100, 10 squared, is 24. Okay, that's another one of those nice Pythagorean triples. So this is 24. So now I want this angle here. Let's call it, I don't know, alpha. I can then say, so this is for part C. I can say tan alpha equals opposite over adjacent, 24 over 6. And then alpha is the inverse tan of 24 over 6. Inverse tan 24 over 6, which is 75.96. 75.96 or 76 degrees. He doesn't say to round it, guys, so put both answers. Okay, that's question 3. Question 4. Vectors. The points A, B, C, D are the vertices of a quadrilateral such that AB equals that, AC equals that. Okay, fine. Show that for all values of P, A, B, C, D is a parallelogram. Okay, so we've A, B. Let's draw this, guys. Let us draw the parallelogram. So this is A. 7 plus P. So we don't know where P is, guys, so let's just put B here. So that means that this vector there, AB, is 7P, like this. AC is 11I minus PJ, so 11I over this way, minus P, okay, let's just put P here, something like this. This is C, so this vector here is 11 negative P, like this, and then AD is 4I minus 2J, so this is 4I minus, okay, so this is here, and I don't know where we're going, somewhere like minus 2PJ. Okay, so let's draw it, guys. I don't know, something like this here. This is A, C. Okay, I'm guessing that if it's a parallelogram, it's gonna have to be something like this. Okay, fine, let's put it there. This is a D, and this is 4 minus 2P. Okay, so you can see the parallelogram, guys, is kind of, well, it's A, B, C, D, like this. A, B, C, D. Okay, then we have, show that for all values of P, it is a parallelogram. Okay, so if it's a parallelogram, so it's 3 marks. I'm gonna write, let's just do it here. If, actually I'll move this here. Okay, if it's a parallelogram, part A, if parallelogram, if it's a parallelogram, AB must equal DC, AB equals DC, and the other side must be true, BC must equal AD, BC equals AD. Now guys, in a show that question, you got to say what you're trying to do, right? So just write as clearly as possible. You can write in English, whatever, however you want to put it across, but you need to get across to the examiner what you're doing. So if it's a parallelogram, AB equals DC and BC equals AD. Okay, so we need to find DC. So DC, how do I get DC? Well, to get from D to C, I can go D to A and A to C. So DC is equal to DA plus AC, like this. Okay, DA is negative this, as negative 4, and then plus 2P, plus AC is 11 minus P, 11 negative p, and this equals 11 minus 4 is 7, and 2p minus p is p, 7p. That is AB. So I'm going to say equals AB. So that's the first one. True, AB equals DC. And then the next one we need is to find BC. So BC, let's do it here. BC is equal to, let's do BA plus AC. So we're going B to A and A to C. Okay, BA is negative this, so it's negative 7 minus P, plus AC, again, is just 11 minus P. This is equal to 4 minus 2P, which is equal to AD. Therefore, A, B, C, D is a parallelogram. Okay, so now you've proven it. Parallelogram. Okay, part B. Given that BD is 3 root 10, find the possible values of P, so the magnitude of BD. Okay, so we've got, well, have we got BD, guys? We have not, but let's get BD. So I'll do it here, just so we can see. BD, the magnitude, is equal to, well, sorry, let's get BD first. BD equals B to D. So I'm going to go to B to A, which is minus 7 minus P, BA plus AD. So plus 4 minus 2P. And this is equal to negative 3 and minus 3P. So that is BD. So now the magnitude of that equals 3 root 10. Let's do it here. The magnitude of this, so the magnitude, guys, is the square root of this squared plus this squared. I get rid of the negatives, guys, just because I can, because 2 negatives squared is a positive, makes it easier. That squared, careful, that squared plus that squared must equal 3 root 10, because he says it here. Find the possible values of P. Now I just have to solve this. Square both sides. This is 9 plus 9P, guys, if I multiply it out and square it. I'm going to square this. This is 9 times 10, which is 90. Do that on your calculator if you need to. Divide everything by 9, and I get, divide everything by 9. Sorry, that's 9P squared, guys. Sorry, mistake there. Divide everything by 9. I get 1 plus P squared equals 10. P squared equals 9, and then P is equal to plus or minus 3. Now he says the possible values, so there's 2 values, and that's the 2. Okay, finally, part C, find a unit vector which is parallel to BD. Okay, so the unit vector, okay, parallel to, now the BD is minus 3 minus 3P. Minus 3 minus 3P. So the unit vector, if you remember how to do it, guys, you just divide the vector by the length. Now, does he want it in any particular form? No. So he says, given that P is greater than 0. Okay, so now P is greater than 0. So our so P is equal to 3. Therefore, this vector is negative 3 minus 9. Negative 3, negative 9. Okay, so the unit vector is sometimes called a hat, guys. A hat on the vector is equal to the vector negative 3, negative 9 times 1 over the magnitude. Now the magnitude we know is to be 3 root 10, so it's 1 over 3 root 10 times this. You could also write that as negative 3 over 3 root 10, and then negative 9 over 3 root 10. And if you want you can write that, guys, as negative 1 over root 10, and then negative 3 over root 10, and they're all the same thing. But to be honest, guys, that is perfectly fine. Okay, that is question 4. Question 5. Given that alpha and beta are such that alpha plus beta is this, alpha beta is this, form a quadratic equation with integer coefficients that has roots alpha and beta. Okay, easy to do this, guys, if you know how it all works. We know the sum of the roots is minus b over a. So minus b over a is equal to 7 over 2. And c over a is equal to 2. Now you can let a equal anything. So minus b, let's just say that, let a equal 1, just to find some quadratic equation. So let a equal 1. So we have negative b equals 7 over 2, and we have c is equal to 2. So then I can say ax squared, 1x squared, therefore 1x squared, plus bx, sorry, I should have said b is then negative 7 over 2. So plus bx, which is minus 7 over 2x, plus c equals 0. And then I can multiply, sorry, the c is 2. Plus 2 equals 0. Multiply across by that 2, and I get 2x squared minus 7x plus 4 equals 0. Okay, form a quadratic equation with integer coefficients that has roots alpha over beta and beta over alpha. Okay, so now the sum is equal to alpha over beta plus beta over alpha. And this is common denominator, then alpha squared plus beta squared, like this. Okay, so the sum is this, and the product, let's do the product. The product is alpha over beta times beta over alpha, which is actually equal to 1, because those all cancel, so that's equal to 1. And then to deal with this alpha squared plus beta squared, I have to do this thing where I do alpha plus beta squared, which is alpha squared plus 2 alpha beta plus beta squared. And then I can rearrange alpha plus beta squared. If I subtract the 2 alpha beta, I get alpha squared plus beta squared. Now we know that alpha plus beta from part A is 7 over 2, and alpha beta is 2. So 7 over 2 squared minus 2 times 2 equals alpha squared plus beta squared. This is 49 over 4 minus 16 over 4, and this is then 33 over 4. Okay, so alpha squared plus beta squared is 33 over 4. Now I'm going to put that in here. So the sum is therefore equal to alpha squared plus beta squared, which is 33 over 4, over alpha beta, which is 2. So this is 33 over 8. That is the sum of the roots. The product of the roots is 1. Does he want integer coefficients? Yes, he does. So same kind of thing, guys. The sum is 33 over 8. So I'm going to say my minus b over a, or I'm going to let a equal 1. So minus b is equal to 33 over 8. My c equals 1. So I have ax squared, 1x squared, plus, well, again, this is minus b. So b is minus 33 over 8. So minus 33 over 8x plus c, which is plus 1, equals 0. Multiply across by 8. 8x squared minus 33x plus 8 equals 0. Okay, that's question 5. Question 6. Okay, so we're given this diagram. This kind of explains it. It says show the point A has coordinates 3/2, 3/4. A is the point of intersection. So firstly, guys, this is the line. I can rearrange this into y equals x over 2. So that's the line. The point of intersection is where they meet, so where they are equal. So I'm going to say, where does x over 2 equal 2x minus x squared? And this is a quadratic that we need to solve. Let's multiply everything by 2 to begin with. 4x minus 2x squared. Bring this over here. This will be 2x squared minus 3x, if I subtract the 4, equals 0. Factorize 2x minus 3 equals 0. X equals 0, or 2x minus 3 equals 0. And here 2x equals 3. X is equal to 3/2. So that's our 3/2 here. But y, we know y is equal to x over 2. So y is equal to 3/2 over 2, which is 3/4. Therefore, A is 3/2, comma 3/4. Part B. The region R is rotated through 360 degrees around the x-axis. So this is a volume of revolution. Use algebraic integration to find the volume of the solid formed. Okay, so it's the volume of revolution. There's 2 of them, so we need to do the quadratic minus the straight line. The formula, guys, is the integral from, so this is the volume, is equal to, well, pi times the integral. You can put the pi in or out. A to B of y squared dx. So we're going to do the volume of, well, we'll do the volume from A to B. So A is 0 because we're going from here to here. We're going from 0 to A. Let's just put this like that. That is 3/2. So from 0 to 3/2. And we are going to put, let's put the pi there. And we're going to square the y. So we're going to do the quadratic squared. So that is 2x minus x squared. And we can do it in one integral, guys, which I think I will do. We're going to minus the x over 2 squared, like this. There we go. The integral of this will give us the volume that we want. Okay, so it's pi times the integral from 0 to 3/2, and then we're going to square this out. This will give us 4x squared minus 4x cubed plus x to the 4, just make sure you're okay with that, guys, minus x squared over 4 dx. And I'll keep going, guys, not integrating yet. 0 to 3/2, 4x squared over 2, that's 4x squared, which is 16x squared over 4 minus 1x squared over 4 is 15x squared over 4 minus 4x cubed plus x to the 4 dx. Now I will integrate and sub in the stuff. Guys, you could have integrated the quadratic and then done the volume of the cone. If you rotated this triangle, you get a cone, but I don't know which way is easier, whichever way you want. So pi times, now we'll integrate, so bracket, this gives me 15x cubed over 12, because it's 3 times 4, minus 4x to the 4 over 4, they cancel nicely, plus x to the 5 over 5, all from 3/2 to 0. Equals, when I sub in the 0, guys, I'm just going to get 0, so that's good. A 3/2 here, so that's, by the way, that goes in 4 and 5, so that's 5 times 3/2 cubed over 4 minus 3/2 to the power 4 plus 3/2 to to the power of 5 all over 5, and then a big minus 0. This is equal to, alright, you can put that in your calculator, guys, if you want. I'm just going to do a little bit more. That's 3 cubes, 27. 27 times 5 is 135. That's 135 over 8 times 4, which is 32, minus, guys, yeah, just use your calculator, 81 over 16, plus 3 to the power of 5 is 243. So it's 243 over 32. 32 times 5 is 160. And, right, hopefully, guys, this is correct. It is 135 over 32 minus 81 over 16 plus 243 over 160, which is 27 over 47, which is correct. So it's 27 over 40 pi. Okay, good. That, guys, is question 6. The 7th term of a geometric series is 192. 8th term is this. Find in a fraction the 4th term. Okay, so, guys, let's work this out. So if the 7th term is 192, let's do it here, and the 8th term is that, then, well, obviously this times or gives me this. So so we have 1152 divided by 192 is equal to the common ratio. Now that is equal to 1152 divided by 192 is 6. Okay, so the common ratio is 6, and he wants the 4th term. Okay, so u4 times the common ratio gives me u5. Again, gives me u6. This gives me u7. So u4 times r cubed is equal to u7, which is, and I'll write it after, 192. So u4 times 6 cubed equals 192. u4 is equal to 192 divided by 6 cubed, which is 192 over 6 cubed, which is 8 over 9. Seems like a reasonable answer. Okay, that is part A. Part B. A different geometric series G has a common ratio or an nth term Tn. Given that T3 is equal to this, T2 plus T3 plus T4 is equal to this, show that or satisfies this equation. Okay, so let's figure this out. T3 is equal to this. Okay, so T1 is the first term. If we do T1 times 2, or sorry, T1 times or gives me T2, and T1 times r squared gives me T3, which is 24. Okay, so I can kind of write everything in terms of T3. So T1 is equal to T3 over r squared, and T4 is equal to, and actually, sorry guys, I just need I need T, hang on, let me start this again. Sorry, okay, I can write T2, T3, and T4 in terms of T3. So T2 times R equals T3. And that means T2 is T3 over R. And then T3 times R equals T4, which means well, actually, sorry, I can just leave it like that. Okay, so this means that T2 is equal to 24 over R, and T4 is equal to 24 times R. So now I have everything in terms of T3, T2, and T4 in terms of R, which gives me, I can then say T2, so T2 plus T3 plus T4 equals negative 36 from here. T2 I can write as 24 over R. T3 I can just write as 24. And T4 I can write as 24R equals negative 36. Why not divide everything by 12 first, guys? I think that would be nice. No, divide everything by 12. I get 2 over R plus 2 plus 2R equals negative 3. Then times everything by R, giving me 2 plus 2R plus 2R squared equals sorry, I forgot to multiply. Oh no, sorry, I didn't. This is equal to negative 3R, and then add this over here, and I get 2R squared plus 5R plus 2 equals 0. Okay, fine. Given that G is convergent with sum to infinity S, part C, find the value of S. Okay, so we have now this, so I can find R. Let's go to C. I can factorize this. Let's just do it here. 2R and R, 2 and 1, plus and plus. So 2R plus 1 equals 0, or R plus 2 equals 0. R is equal to negative a half. R is equal to negative 2. Now, if it is convergent, that means the magnitude of R has to be less than 1. So this, therefore, R equals negative a half. So R is a negative a half. The first term, T1, I need to get, let's get this here. We know R is negative a half. T2, what is T2? T2 is 24 over R. So T2 is equal to 24 divided by negative a half, which is negative 48. And then I can find T1. T1 is negative 48 divided by negative a half, which is 96. Okay, so the sum to infinity is A over 1 minus R, which in this case is A 96 over 1 minus negative a half. So I need to do negative half like this, and I get 96 over 3 over 2. You can do that in your calculator, guys. It's 96 divided by 3 is 32. 32 times 2 is 64, which is correct. Okay, guys, that is question 7. Given that y is equal to this, show that this is true. Okay, so essentially, guys, we need the first derivative and the second derivative, and we can just form this equation quite easily. So, first derivative, y is equal to e to the 3x sine 2x. This is definitely, guys, a product rule. So product rule at the side will say u is e to the 3x, v is sine 2x, u dash is 3e to the 3x, careful, that's a chain rule, and v dash is 2 cos 2x, be careful, also chain rule. So dy dx is u times dv dx, so this times this plus this times this. This times this is, I'll just go down here, guys, 2e to the 3x. this times this, cos 2x, plus this times this, which would be 3e to the 3x times sine 2x. Okay, this is dy dx. Now I need the second derivative, which would be the derivative of this, d2y dx squared equals. It's an 8-mark question, guys, but it's actually not bad. It's just long and annoying. But this is just a product rule, and this is another product rule. So let's do them both over here. U is equal to 2e to the 3x, v is equal to cos 2x, du dx, or let's just go u dash is equal to 6e to the 3x, multiplied by that 3, and v dash is equal to 2 negative 2 sine 2x. And then this guy I'll do here, u is equal to 3e to the 3x, v is equal to sine 2x, u dash is 9e to the 3x, v dash is 2 sine 2x, this times this, this times this, this times this, this times this. So d2y dx squared, let me just, guys, make a bit of space. Okay, this is equal to this times this plus this times this. Okay, so that's going to be negative 4e to the 3x sine 2x plus 6e to the 3x cos 2x. And this times this, so it's plus 6e to the 3x sine 2x plus this times this, 9e to the 3x sine, sorry guys, I've made a mistake, that's 2 cos 2x, so 9e to the 3x sine, sorry, 9e to the 3x sine 2x. Sorry, this one's cos then. Sorry guys, cos 2x, and then this is sine 2x. Okay, let's just simplify this, guys. This and this can become 5 sine 2x, and this plus this would be 12. Sorry guys, I'm not on it today. It's 5e to the 3x sine 2x plus 12e to the 3x cos 2x. Okay, so this is d2y dx squared, and this is dy dx. So let's do this. We'll do d2y dx squared plus, no, sorry, minus 6 dy dx plus 13y. So I'm going to sub these things into this. So this thing first, so it's 5e to the 3x sine 2x plus 12e to the 3x cos 2x minus 6 of these. So 6 of these is 2e to the 3x cos 2x plus 3e to the 3x sine 2x. Close this, and then it's plus 13y, so it's 13 of these, 13 e to the 3x, so it's plus 13 e to the 3x sine 2x. Sine 2x. Now, I can't just say this equals 0, guys. I need to show that it's equal to 0, so let's do that. This is 5e to the 3x sine 2x plus 12e to the 3x cos 2x minus 12, I'm going to multiply this out, minus 12e to the 3x cos 2x plus 18e to the 3x sine, sorry, that's a minus, sine 2x plus 13 e to the 3x sine 2x. Hopefully, guys, this all becomes 0. So I have the 5 sine 2x minus 18 is, so that's 5 minus 18 is minus 13, plus 13 is 0, so that's good. That, and that is 0. And then the 12 e to 3x cos 2x minus 12 e to 3x cos 2x, also 0. Great. So this equals 0, Q, E, D. Okay, that, guys, is question 8. A curve has this equation. The curve crosses the y-axis at the point A. The line L with equation this is normal to the curve. Show that P is equal to 1. Okay, so okay, crosses the y-axis. So, guys, a few buzzwords here that we need to underline. So crosses the y-axis, that is when x equals 0. Normal to the curve, that means the gradient, this guy's gradient is 1, so our, let's just write this here, dy dx is equal to -1. So that's just two things to consider. Okay, so when x is 0, at x equals 0, y is equal to 0 over 0 minus 2 over minus p, which is 2 over p. So 2 over p, but so y is 2 over p, so 2 over p must equal 0 plus 2, because this equation is touching the graph. Because if it's normal here, so the graph looks, I don't know, looks something like this. If the okay, it might actually look something like this. So let's say the normal to the graph is something like this. So there, that means it's touching at that point. So the y coordinate of the line and the graph have to be equal. So 2 over p, I'll just remove that, guys, because that may not be what it looks like at all. So the 2 over p must equal the line at this point. So 2 over p equals 2, 2 equals 2p, and then p equals 1. So that's ai, and then ii, find the value of q. So look at this. If this is the normal and it has a gradient of 1, the gradient of if the gradient of the normal is 1, the gradient of the graph is -1. So I'm going to get dy dx. Dy dx is equal to, it's a quotient rule, guys. It's v times du dx, so v times du dx, which is q. Do this the long way, guys, but I'm just going to do it the quick way. Minus u times dv dx, qx minus 2, all over this, all over v squared, x minus p squared. Now we know p is 1, everybody, so I'm going to put 1 in for p, and I also know at this point that, well, what do I know? Let's see. Well, I know this is equal to -1. Okay, so I'm going to put 1 for p. So this is x times q, because this is, sorry, it's 1. X minus 1 times q minus qx minus 2 all over x minus 1 squared. This must equal, it must equal -1. Now what is x at this point? Well, at this point x is 0, because this is where it crosses the y-axis. So x is 0. I'm just going to write that here. At a, x equals 0. Okay, so that makes life a bit easier. I'm going to make this minus q minus 0 minus 2, so that's going to be plus 2, all over 0 minus 1 squared, which is 1 squared, which is 1, good, which is equal to negative 1. Okay, fine. Minus q plus 2 is negative 1, minus q equals negative 3, and then q is equal to 3. Okay, great. Then he says, using the axes on the opposite page, that's this one here, sketch C. Okay, so I'm just going to write it out, guys, with q and p. So it's 3x minus 2 over x minus 1. That is what we are trying to sketch. Okay, to sketch these graphs, everyone, we need the x-intercept. X-intercept is when y is 0. When y is 0, when y is 0, 3x minus 2 is 0, x, so 3x minus 2 equals 0, x equals 2 over 3. We need the y-intercept. The y-intercept we know is when x is 0, so it's just 2, y equals 2. We need the horizontal asymptote. The horizontal asymptote is when x approaches infinity, so the coefficients of x dominate, so we get y equals 3 over 1, or 3, and we need the vertical asymptote. The vertical asymptote is when the denominator equals 0, which is 1x equals 1. Okay, I put in my asymptotes. Horizontal is y equals 3. Let's put it here, and I write y equals 3. The vertical, you don't have to use different colors, guys, but I'm just going to do it. The vertical is 1, so I'm going to put it here. X equals 1. And then I need these intercepts. So the x-intercept is 2 over 3, which would be somewhere here. I'm going to write it, guys. This is 2 over 3, 0. He says showing clearly asymptotes and the coordinates where it crosses the axes. And then this is 2, which would be about here. Let's put 0, 2. And then it's, well, it's just going to look like, it's going to look like this. So, well, I was right the first time, guys. Something like this. Don't let it touch the asymptote, and try and draw it a bit better than me, guys, but something like that. Okay, that is part, sorry, it was actually just part B. Okay, finally, part C. Let's do it here. The line L meets C again at the point D. Find the x-coordinate of D. Okay, so essentially, guys, what's happening is the normal is like here. Well, it's, I don't know, it's going through this point. It's normal to the curve, and then it's hitting this curve again here. So we're going to get one answer is 0, and the other answer is, well, whatever that x coordinate is will be our solution. So we need to equate the line. So the line, guys, is just x plus 2 to this curve. So x plus 2 equals 3x minus 2 over x minus 1. And then we solve this. We'll get two solutions. X equals 0 is one of them, and the other solution is, well, the answer to the question. So multiply across, x plus 2 times x minus 1 equals 3x minus 2. Multiply this out, x squared minus x plus 2x minus 2 equals 3x minus 2. X squared minus, sorry, plus x minus this is minus 2x. They're gone, equals 0. Factorize x minus 2 equals 0. X equals 0, or x equals 2. Therefore, the answer to the question, the x coordinate of D, x coordinate of D is 2. Now always be careful, guys. Does he want the y coordinate as well? In this case he doesn't, but if he did, he would just sub it back in to one of the y equations and you would get it. Okay, that, guys, is question 9. Question 10. Okay, guys, this is 2 lines and 9 marks. You know this is going to be hard, but hopefully it'll be fun as well. The volume of a sphere is increasing at a constant rate of this. Okay, firstly, guys, what is that? That is dV dt. Find the rate of increase in centimeters squared per second of the surface area. So we're trying to find, let's call it SD. No, actually, let's call it A for area. dA dt when the radius is 4. When radius equals 4. Okay, now it's a sphere. A sphere has a volume of 4 over 3 pi r cubed. Okay, now we want to get dA dt, the surface area of a sphere is equal to 4 pi r squared. Okay, now with this I can get dV dr. Let's just get that. dV dr is this times this. Well, it's actually going to be that, guys. It's going to be 4 pi r squared. Okay, so dV dr is 4 pi r squared. And dV dt is 40. What we want is dA dt. Okay, so dA, I can get here dA dr. dA dr is 8 pi r. Okay, now I want dA dt. dA dt is going to be dA dr times dr dt. So I need to find dr dt, and I'll find it from this dV dr thing. So because I know dA dr is 8 pi r, I don't know dr dt. So let's go back to this. dV dt, let's do that. dV dt is dV dr times dr dt. Now we know dV dt is 40. So 40 equals dV dr, which is 4 pi r squared, times dr dt. Now we're trying to get this whole thing when r equals 4. Okay, so this is when r equals 4. So when, let's do this, dr dt is therefore equal to, I'll divide by 4, guys. So it's going to be, well, that's going to be 10, and that's going to be 1. So it's going to be 10 over pi r squared. Let me just do this. At r equals 4, dr dt equals, well, actually, I could just sub all this in here right now and then put it equal to 4. So dA dt equals dA dr, which is 8 pi r, times dr dt, which is 10 over pi r squared. And then at r equals 4, which is this, I can say dA dt equals, the pi's cancel, one of the r's cancels, so I'm just left with 80 over 4, which is equal to 20. So therefore the answer is 20 centimeters squared per second. Okay, so I don't know, guys. I don't know if that's the quickest or easiest way to do it, but that kind of made sense to me. So hopefully it did to you too. That's question 10. Question 11. Express the equation here in this form. Okay, so guys, this is the compound angle identities from the formula sheet. You can have a look if you need to, guys, but this is 3 sine, it's 3 sine A cos B minus, and there's a bracket there, minus sine B cos A, and this equals sine A cos B plus plus sine B cos A. Okay, so he wants this equation in this form, tan A tan B, right? So to get tan A, guys, here I think we should just divide everything by I think we'll divide everything by cos A. Hang on, let me think. What's the best way to do this? I think if we divide everything by, let's divide everything by cos A. By cos A sine B. Okay, that might work. So I'll do this divided by, so it's 3 sine A cos B over cos A sine B. So I'm just going to divide every term by that. I'm just going to multiply this out in the process. So that would be minus 3 sine B cos A divided by the same thing, which is cos A sine B, equals sine A cos B over cos A sine B, and then I'll just go over a bit here, plus sine B cos A over cos A sine B. Okay, this becomes sine over cos, which is tan, and cos over sine, which is well, it's 1 over tan. So this would be 3 tan A over tan B. So just to be clear how I got that, guys, it's if sine over cos is tan, cos over sine is 1 over tan, hence the tan B at the bottom here. This is actually just going to equal, 1. Well, these cancel, so it's going to be minus 3. This is then similar thing. This is tan A over tan B, and this is plus 1, because this goes with this and this goes with this. Okay, so now I have 2 tan A over tan B equals, or minus 3 equals this. Let's get everything on the left. So I can say, or I can multiply by tan B, actually that might be the easiest thing to do. So 3 tan A minus 3 tan B equals tan A plus tan B. So I've just multiplied everything by tan B, and then get, what does he want? Tan A is on the left and tan B is on the right. So this will be 3 tan A minus tan A is 2 tan A equals 3 tan B plus tan B, which would be 4 tan B. So tan A equals 2 tan B. And that's it. So K would equal 2. Okay, that was a kind of annoying question, right? Part B. Given this, show that this equals this. Okay, so guys, he's only saying given this because the denominator can't be 0. You can basically ignore that whole thing, although n is an integer, might be important. So, oh no, sorry, it's not. That's just part of that, so you can just ignore that. Okay, so here we have to show this is equal to 1 minus tan squared theta. You cannot use, guys, the 1 minus tan squared theta. I'm going to show that. Okay, so this over this is equal to, okay, this, guys, is a difference of 2 squares. This is actually, this is like cos theta squared minus, sorry, that's not true. It's like cos squared theta squared minus sine squared theta squared. That's like power of 4, and that's to the power of 4. Difference of two squares means I can say this is equal to this plus this times this minus this. So that's, hopefully guys, you're okay with the difference of two squares. Cos squared theta plus sine squared theta times cos squared theta minus sine squared theta. And this is all over cos squared theta. Now, we know, everyone, that this equals 1. So this is just equal to 1 times cos squared theta minus sine squared theta over cos squared theta. But that equals cos squared theta over cos squared theta. Now note, guys, it's a show that, so I'm really just showing all the steps. Cos squared theta over cos squared theta minus sine squared theta over cos squared theta. And that is equal to what they wanted me to prove or show, 1. So that equals 1 minus, this is tan squared theta. Okay, that is part B, Q, E, D. Part C. Use the exact values of sine, cos, and tan for 34, 45, and 60. Show this. Okay, I'm just going to, guys, let's just bring this whole thing down here. Okay. So I'm assuming we're going to use some of this thing here, guys, or maybe not. So cos of 15, okay, part C, cos 15 degrees is equal to, let's go with cos 45 minus 30. Now, cos 45 minus 30, this is equal to cos squared 45 minus sine squared, I'm sorry, that is not true. What am I doing? It's cos 45 times cos 30 minus sine 45 sine 30. That is the addition formula for cos A minus B. I'm sorry, that's plus. Okay, so this, that's in the formula sheet, guys. This is equal to cos 45, you need to know these. Well, you have a calculator anyway. It's 1 over root 2 times root 3 over 2 plus sine 45, 1 over root 2 times 1 over 2. So this is actually equal to, common denominator is already there, 2 root 2, and it's 1 times root 3, which is root 3 plus 1. Now, he doesn't want it in this form, so what do I do? Well, I'm going to multiply above and below by root 2. So times root 2 times root 2. And this gives me, this times root 2 is root 6. This times root 2 is root 2. And this times root 2, 2 root 2 times root 2 is just 2 times 2, which is 4. Okay, easy. Part II. Tan 255. Okay, so this one, guys, is a bit more tricky because it, well, it's not really one of these that we're dealing with, but we know from our cast diagram, let me just, our unit circle, where is 255? Okay, so 255 is down here. 255, where this would be 75. Okay, so we know that, and because it's in like the tan quadrant, C-A-S-T, down here, tan is positive. So this is actually the same. I can write tan 255 equals tan 75. It's the same sign and everything. Okay, so now I can just do tan 75, which is equal to tan 45 plus 30, which is a nicer, well, nicer two angles that I can just add using the addition formula. So this is tan 45 plus tan 30 over, this is in the formula booklet, guys, 1 minus tan, is it minus? I think so, tan 45 times tan 30. Okay, and this, well, I know the answer, so we'll find out. This is equal to 1 plus tan 45 is 1, tan 30 is 1 over root 3, all over 1 minus 1 times, and that's also 1 over root 3, multiply, guys, everything by, well, the easiest way to do this actually is if you multiply everything by 3 root 3, because I'm trying to get this. So if I do this times 3 root 3 and this times 3 root 3, I get 3, actually, sorry, if I just multiply everything by 3, this times 3 and this times 3, that will give me the 3's there, and you'll see how the rest works out. So it's 3 plus 3 over root 3 over 1 minus 3 over root 3, and this is equal to 3 plus 3 divided by root 3 is root 3, and then similarly here, sorry, I forgot to multiply this by 3, similarly here is 3 minus 3 divided by root 3 is root 3. Okay, that's the paper done, guys. Let me know what you think in the comments, but I actually think that was not a bad paper considering how hard some of them are. Anyway, there you go. That is paper 2.